Members of the IFC committees, guests, my name is Scott Brody. I hold dual degrees in civil engineering and urban planning and conducted a thesis on street design. I went on to write a book on fire access. I did a companion cost study, and I presented on these issues at the National Fire Protection Association and the Congress for the New Urbanism. This statement summarizes my work. Further information will be provided to you as the proposal is finalized, and I will also note that the book and study have completed drafts, but they're undergoing revisions. So why am I speaking here? Our nation is in the midst of a road safety crisis. In 2019, Oslo and Helsinki had 1 in 3 traffic deaths. Similarly sized American cities had 27 to 67 fatalities on their streets. Traffic fatalities kill 11 times the number of people as fires and leave many more injured. Local and collector street design is highly controlled by the IFC. Over 4,000 fatalities commonly occur on these streets. This is more than all fire deaths most years and suggests major safety interventions are necessary to improve conditions on the lowest classes of road. The IFC specifies streets used for fire access must be 20 to 26 feet wide, excluding parking and shoulders. It bans all traffic calming, unless the fire official, who has no training in traffic safety, grants an exemption. This is a major problem for road safety, because studies have shown at the IFC's minimum widths, drivers tend to travel at a speed where the pedestrian fatality risk is 5 times higher. Additionally, there's a great increased risk for motorists. When London went from wider to narrower local streets, killed and serious injury collisions fell 53%, while deaths for car occupants fell a whopping 77%. In Denmark, a combination of 30 and lower 15 km/h streets lowered casualties per user kilometer by 72%, while serious injuries fell 78%. Time and time again, studies have shown that traffic calming and narrower streets save lives. There's no reason to believe similar changes wouldn't work in the United States. The tragedy doesn't end there. Data shows going from even 1 to 2 lanes significantly impacts people's desire to walk. Wider roads also have a tendency to filter traffic onto arterials, where unhealthy drive-throughs, not sidewalk cafes, dominate. The US has an obesity rate 2.5 times that of Europe, which reduces overall life expectancy by 2 to 4 years. Rather than focus on rare causes of death, we must re-examine the illegalization of old city forms. Communities with beautiful winding streets, where the streets are the experience, tend to have better health and life expectancy, at least among similarly economic nations. It's time our codes grant citizens the right to choose neighborhoods that put health first. Along the lines of health, some people claim that narrower streets should be illegal because they delay ambulances. My preliminary calculations suggest wide roads do not save more lives than they kill. I will be working to get the committee numbers for ambulance services and fire departments before the final proposals are due. For those who are still not comfortable with any changes that could negatively impact emergency response outcomes, consider how much money is spent on roads. The US disbursed $266 billion, and this doesn't even count expenses like homeowners association communities, shopping center roads, or the cost developers pay to build new roads, which they ultimately turn over to the government. My cost analysis, being submitted with this proposal, estimates switching from strict compliance with IFC dimensions to context-sensitive widths specified in the Institute of Transportation Engineers and American Association of State Highway and Transportation Official Standards could save $85 per household per year in annual maintenance, plus $6,800 in new construction expenses. Based on trends we're seeing in actual street design, there's a potential also to save a little less than that, but most of the codes are pretty close to the IFC and NFPA dimensions. Most of the streets are. Note that these numbers are preliminary and may be adjusted slightly following additional peer review. In any case, the cost of paving, land acquisition, and other items for wider roads comes out to a huge amount. For this money, A typical suburb of 30,000 people could add over a dozen full-time fire crew and outfit all homes with sprinklers. Structures with sprinklers have a death rate of 0.7 per 100,000 fires versus 6.7 per 1,000 fires in unsprinkled scenario. Hiring crew also appears to be more effective than widening the roads. It's time we support safer and more effective fire prevention measures than streets for speed. Another option which could potentially be combined with some staffing or building upgrades is smart growth. This planning concept supports building communities with denser centers and more interconnected streets. The denser centers mean that there's less travel distance for emergency services, and the interconnected streets shorten the distance and provide redundancy in the event one route is blocked. Under the current IFC, to avoid speeding cut-through traffic, developers are allowed to plan neighborhoods with highly disconnected street grids. You can build cul-de-sacs on two ends and no connection between them. This is far more delaying than the illegal by right solution of traffic calming or narrowing. Another issue is the impact of regulations on building size. Because structures which require traveling a long distance on foot or elevators, you have to park the apparatus to get to and travel on foot to get to your final destination. This can result in far more delay than the traditional urban form. A justification for keeping their current rules has been that fire services need space to set up hoses, ladder truck stabilizers, and pass. Regarding outriggers, the 26-foot width in the IFC is unnecessary in most cases. Short jacking technology is widespread, which allows outriggers to only be deployed on the side where they are being used. Trucks can also be built with narrower or straight down outriggers that consume no space. If you don't have a truck with these capabilities, other tactics exist. For example, the area in front of driveways naturally creates a no parking zone to place outriggers or conduct other staging activities. Many times, there are also empty on-street parking spaces, particularly in lower density suburbs where all homes have garages. If parked vehicles are still a challenge, many of the latest trucks have camera technology which more easily allow outriggers to be placed between cars or other obstructions like bollards. Other trucks also have underslung outriggers which fit under parked vehicles. If there still isn't room, it only takes a few seconds to snap on a set of vehicle dollies and push any vehicles that are out of the way to where they need to go. Further options include placing outriggers on the grass or the sidewalk with stronger support pads. On the hose side, the IFC commentary says additional road width is necessary because hoses are inflexible. Rather than widening the road, a simple alternative is to push hydrants back so the line into the pumper has more room to bend away from the road. If there are multiple engines on scene, and some are not in front of a hydrant no parking zone, operators can be trained to park aligning these engines with their side hose connections between parked vehicles. Rear and front mount connections are another option if the department is equipped with these. Regarding attack hoses, these should have the ability to bend around obstructions because they're lower flow and they get carried into buildings where they're going to need to bend a number of times anyway. Regarding passing, I will again note that lower density suburbs tend to have garages and room to park in driveways, so passing is often a non-issue. If it's not raining, passing can also be done on the grass in many rural areas. But what about the worst case scenario? All the parking full. Well, passenger cars and smaller emergency vehicles can make room for others by pulling into the space in front of driveways, which naturally creates a no parking area. But what about truck passing? Well, the IFC's dimensions don't reflect the size of today's vehicles, so truck passing is often not possible. Fire apparatus can be up to 10.5 feet wide, including the mirrors, per industry standards. Though many apparatuses are a bit narrower, there's a 6-foot parking standard which doesn't reflect design vehicles as well, and there's a driver limitation. So with all these factors combined, passing is often not possible under the existing code. In fact, even the Dutch code requires wider widths when truck passing is required. This makes sense given that trucks are in both Europe and the US cap out at around the same width based on the internationally standard container size. Rather than focus on unlikely scenarios and have dimensions that fail in such cases, fire codes would be wise to learn from transportation engineers and leading nations for fire safety around the world, and adopt widths that are more risk-based. With all the problems associated with the old method, there's also been legal changes which justify re-examining the current code. In 2015, Congress passed required roadway design regulations place greater emphasis on elements including safety, the environment, aesthetics, and context sensitivity. In 2021, the safe system approach to road design, pioneered in Europe, was enshrined into US federal law. AASHTO's policy on geometric design and its companion guidelines for low-volume road have been updated and now conflict with model fire codes. The updated AASHTO guidelines were incorporated into federal regulations in 2022 and are thus required to be complied with on many projects receiving federal funding. States also commonly adopt these standards. ICC Code Council Policy 49-21 requires codes not conflict with US law. I'm asking the committee to update their model codes to be consistent with the latest AASHTO policy as incorporated into the Code of Federal Regulations. Continuing down the path of the existing fire code could also subject the ICC to civil torts, and therefore it needs to be re-examined. Numerous state courts have found standards developers can be held liable for defective standards if they become aware of a hazard, there's a way to abate such hazard, and they don't take action. A notable example of this was the National Spa and Pool Institute, an organization that, like the ICC, followed ANSI procedures. They had to declare bankruptcy after numerous lawsuits stemming from a hazard to divers that wasn't properly addressed. Another liability is antitrust law. The Standards Development and Organization Act of 2004 provides antitrust immunity to standards developers, but there are certain limits. Standards must be developed in a balanced manner. The ANSI, also American National Standards Institute, ANSI, also has rules that a single interest cannot dominate to the expense of others. In a letter to ANSI, the US Department of Justice clarified that dominance can include state interests. While the IFC has adopted procedures for balancing the appointment on code committees, it should be noted that the latest law and regulations suggest such quotas in themselves may not solve the problem. It's decision-making that has to be balanced. And right now, I have concerns that issues such as road safety, health, the environment, and housing affordability haven't really been treated equally. In addition to US law, ICC Code Council Policy 49-21 specifies codes should not conflict with international law, nor be written in a way which makes them not well suited for international adoption. The United Nations has passed numerous resolutions on road safety and now calls for safer, slower street designs around where people live, work, and play. I call on all of you to make your standards consistent with UN resolutions. Another aspect of international law is trade treaties. The United States is a party to the World Trade Organization Technical Barriers to Trade Agreement. This obligates jurisdictions to give positive consideration to accepting foreign standards as equivalent, provided the same objectives are met. Since many countries have better fire safety and cardiac arrest survival, despite not having wide roads, it's time we look at what they're doing and if there's ways to provide an alternative pathway under the I codes. The requirements I mentioned might seem procedural, but history shows why elements like balance are really important. In the past, model fire codes refused to remove asbestos mandates years after the substance's hazards became known. Fire code officials really didn't take balance seriously, and things like health weren't treated the same as fire safety. Today, more people continue to die from asbestos-related illness than all fires. Much of the asbestos problem can be traced to the era around 1970, when scientists warned of the substance's terrible dangers, but fire officials resisted change in codes, and on the local level, buildings were forced into compliance with unsafe standards. A similar phenomenon later happened with cancerous flame retardants. Today, thousands of Americans are dying in entirely preventable traffic crashes. I hope history doesn't again repeat itself. And I look forward to working with you to ensure that's the case. Thank you.